Hey everyone, and welcome. You hear the term data science thrown around all the time, right? But what does it actually involve? Well, today, we're going to pull back the curtain on the step-by-step process that transforms messy, raw data into clear, real-world answers. Let's get into it.
So let's start with something we all get. You open your music app, you're ready for a workout, you hit a button, and boom, it just serves up the perfect high-energy playlist. How in the world does it know? Is it magic? Are they just taking a wild guess?
Well, no surprise here, it's not magic. It's actually a structured, methodical process. There's a clear journey that goes from collecting data on all the songs you listen to all the way to deploying a model that predicts your next favorite jam. And we're going to walk through that journey together, step by step.
And that journey? That's what we call the data science process. Think of it like a roadmap, a system designed to do one thing incredibly well: turn raw, confusing data into clear, actionable insights that help us solve real problems.
So why even bother with a process? Why not just jump in and see what happens? Well, because without one, you're pretty much just guessing. Having a structured approach ensures quality and consistency. You know, it's the difference between a random shot in the dark and a reliable, trustworthy result you can bet on. Now, this whole process isn't just run by one person typing away in a dark room. Not at all. It's a team sport. It really does take a village, a whole squad of specialists, each with a unique and critical role to successfully guide data from a simple question to a powerful solution. And here's a look at the lineup. You've got your data engineers, who are like the architects building the data pipelines. You've got data analysts, who are the first ones to dig in and find initial insights. And, of course, the data scientists, who create those predictive models. Everyone, from the project manager keeping it all on track to the machine learning engineer who actually puts the model out into the world, plays a vital part. But what's really crucial here isn't just what each person can do on their own, it's all about how the team collaborates. The data scientist and the business analyst, for example, have to be perfectly in sync to make sure the technical work is actually solving a real business problem. And honestly, the data scientist can't even get started without the data engineer providing clean, accessible data. It's this constant back and forth that really drives a project forward. Okay, so we've met our dream team. Now let's dive into the journey itself, starting right where you should, at the very beginning, with the foundational steps that can make or break a project. Here it is, our roadmap for the journey. It all kicks off with a clear goal. Then we gather our raw materials, the data. After that, we have to get our hands dirty and clean it up. Only then can we start exploring for patterns, build a model to make predictions, and finally, share what we've discovered. Let's break down those first couple of steps. Everything, and I mean everything, starts right here. Before anyone writes a single line of code, the entire team has to agree on the exact problem they're trying to solve. This means defining a super clear objective and usually creating something called a project charter, which just gets everyone on the same page about the goals and what success is going to look like. Okay, you've got your question locked in. Now you need the raw ingredients. That's the data collection phase. For our music playlist example, this could be your listening history from the company's own database, or maybe even data from IoT devices like a smartwatch or a connected treadmill. The point is, data can come from pretty much anywhere. All right, so we have our data. But here's the thing. It's almost never perfect. In fact, it's usually a bit of a mess. And that brings us to the next absolutely critical phase, turning that messy pile of information into a clean, understandable treasure. Here's a hard truth about data projects. The raw data you get is almost always messy. You'll find things like missing values, often shown as NaNs, which literally just stands for not a number. If you try to feed this messy data directly into a model, you'd either get a bunch of errors or, even worse, a completely wrong answer. So what do? We clean it. This means figuring out how to handle those missing values, getting rid of any duplicate entries, and correcting simple typos or formatting mistakes. Now, this step might not be the most glamorous part of the job, but ask any data scientist. They'll tell you it's one of the most important, and often, the most time-consuming part of the whole process. With our data now sparkling clean, this is where the real fun begins. This stage is called Exploratory Data Analysis, or EDA for short. The best way to think about it? It's the detective phase. You put on your detective hat and use visuals and stats to search for clues, find hidden patterns, and really start to understand the story your data is trying to tell. So what's our mission as data detectives? Well, it's pretty straightforward, but incredibly powerful. You're trying to understand the basic shape and structure of the data, spot any interesting patterns or trends, and identify any weird outliers that just don't seem to fit. The clues you find here will guide everything you do next. One of a data detective's favorite tools is the histogram. It shows us the shape of our data. See this one? It's got what we call a symmetric unimodal distribution. Unimodal just means it has one main peak, right in the middle. And symmetric means it's basically a mirror image on either side of that peak. Seeing a nice, clean shape like this is often a great sign. But what if our data looks more like this? This data is skewed. See how it's all bunched up on one side with a long tail stretching out? This tells a totally different story. Maybe for our music app, most people only listen to a few songs, but a handful of super users listen to thousands. Finding a shape like this completely changes how we're going to approach building our model. So after all that exploring, we're finally ready for the main event, model building. This is the moment we go from just understanding what happened in the past to actually predicting the future. We're going to teach the machine how to think based on all those patterns we just uncovered. And there are two main ways we can do this. The first is called supervised learning. That's where we give the machine tons of labeled examples, like showing it thousands of songs we've already tagged as high-energy workout or chill focus music. The other way is unsupervised learning. Here, we don't give it any answers. We just hand over all the listening data and ask it to find natural groups or clusters on its own. It might just discover hidden types of listeners we never even knew existed. Okay, so we've built our model, and it's making amazing predictions. But all that incredible, complex work, it doesn't mean a thing if we can't translate it into real-world impact. And that brings us to the final, and you could argue, the most important phase of all. The last step is 100% about communication. It's about taking all those complex results, all those numbers and statistics, and telling a clear, compelling story. You use powerful visuals and sharp storytelling to make the findings so easy to understand that anyone, not just the data experts, can see exactly what it all means and what to do next. And as we wrap up, it's so important to remember this. This whole process isn't a straight line with a beginning and an end. It's a cycle. The answer you find at the end of one project almost always sparks the big question for the next one. In data science, finishing one journey just means you're at the starting line for a new, even more interesting one. So there you have it. From predicting the perfect workout playlist to solving massive global challenges, this process is an incredibly powerful tool for turning data into real decisions. Now that you understand the journey, I'll leave you with one final thought. What problem would you want to solve?